Next, we looked at how we can change the decimal into a signed binary using the positional value method. It is very similar to what we have done for unsigned, except that we add another bit to indicate if it's a positive number or a negative number. So to convert the plus 78 base 10 to a signed binary, we first put the positional values just like what we did for the unsigned binary, but we need to add in a sign bit. So let's add the sign bit. Okay. After 64, the sign bit would have the value of the next binary bit, which is in this case is -128. Now, since this is a positive number, the sign bit would be a 0. So we put a 0 for the sign bit because this is a positive number. So this, after which you will then put in you'll do the same thing like what you did for the unsigned binary in order to get the value of 78. So I'll not repeat what we had done previously. 64 can go into 78. So we'll put a 1. And then we subtract 78, subtract 64 will give us the 14. So 32 can go into 14. So we'll have a 0. Again, 16 cannot go into 14, so we put a 0. 8 can go into 14, so we have a 1. So 14 take away 8, we'll have 6. 4 can go into 6, so we put a 1. So the 4 is then we then subtract 6, we'll subtract 4, which is the balance of 2, and 2 can go into 2, so we have a 1, and we have no longer any other no remainder, so the last bit will be a 0. Alright, so we see that for the binary 78 posits and we convert to signed binary, then there is a slight difference. First, there's the positive sign which appears at the beginning of the decimal number to indicate that it's a signed number. So in our signed binary, to indicate that this is a positive number, we have not 100111110 like above, but we have a 0 in front, which is indicative of a positive number. So if we take all this at the top, it is going to be 0 1 0 0 1 1 0. So if we look at the two for the positive signed binary and the unsigned binary, it is very similar, except that the MSB bit is now indicative of the sign. So for a positive number, the sign bit would be 0. So let's recap. To convert a signed decimal to a signed binary, we put the place value, and the most significant bit will be the sign value. So for positive number, we'll put it 0 for the sign bit, and then we use the positional value method to get the rest of the values. We will next look at how we convert a negative decimal number into a signed binary. We will take a negative decimal number, in this case minus 78, the base 10 or decimal. Again, we have the place values, and the most significant bit is again the sign bit, and this sign bit has a place value of minus 128. Now, because it is a negative number, then the sign bit would be 1. Okay, remember, if we have a negative number, then we will have a sign bit which is 1. Alright, because the positive sign bit is minus 128, then 1 times minus 128 will give you a value of minus 128. Now, what we want is that at the end of our work, we are going to get a minus 78. So minus 128 plus a positive number which we don't know, let's call this x, must give us 78, minus 78. So if you do your equations properly, x will be equals to 128 take away 78, which is equals to 50. So the value of x, must appear in this, the equivalent value, binary value of x must appear here. So here you see that the 64 cannot go into 50, so we'll have a 0. 32 can go into 50, so you have a 1. So if you have 50, like before, you take your 32, you subtract it, and what's left is 18. 16 can go into 18, so you put a 16, and what's left is 2. 8 cannot go into 8, 16 to 2, neither can 4, but 2 can go into 2. which gives you a balance of 0. 1 cannot go into 0, so it says 0. So your minus 78 base 10 is equals to 1, 0, 1, 1, 0, 0, 1, 0. And that is the base 2. Alright, so if you compare plus 78, the binary for plus 78 and minus 78, you will notice that because it's a negative number, the most significant bit will be a 1